Today we're going to talk about 2.6, which is absolute value equations. But before we start actually solving equations, we're going to go back to the concept of absolute value. So if we talk about absolute value, the idea of absolute value is a number's distance from zero. So if we think of the idea, absolute value of 5, it means that it has 5 units from zero. Going to the right is easy enough. We see that positive 5 has a distance 5. But the idea of this is that it can also go in the other direction, to the left. So it would also be negative 5. So we end up getting two solutions for this. Absolute value of x equals 5. X could either be positive 5 or it could be negative 5. So it produces two solutions, again, because of distance to 0. So when we go to solve an absolute value equation, I'm going to ask that you set up two equations pretty much every single time. We're going to label one of them A and one of them B. The first equation takes the positive value distance to 0. So y equals 5, so the positive distance. The other equation represents the negative value, so the negative 5. So y equals negative 5. So the first one will be positive, the second one will be negative. Now, in this particular case, we already have the variable by itself, so our solution is negative 5 and 5. Most of the time, you will get two solutions for each absolute value equation. There will be a few examples where it won't, but we'll come to those in a second. So number 2, we see we have an absolute value equation again. So what we're going to do is we're going to just set up two equations. The first one is going to be 4x plus 2 equals positive 6. And the next one is 4x plus 2 equals negative 6. I want you to notice two things. I did not change anything that was inside the absolute value bars. So it stayed exactly the same. One did not become positive, one did not become negative. They stayed exactly the same. The only difference was what it equal to changed. So when we go to solve this, and we subtract 2, and I get 4x equals 4. I'm going to divide by 4, and I get x equals 1. Over here, I'm going to subtract 2, and we're going to get 4x equals negative 8, and then we divide by 4, and we get x equals negative 2. So my solutions are negative 2 and positive 1. A way that we can always double check these solutions is if we plug it in. So if I plug in negative 2, so my check, 4 times negative 2 is negative 8 plus 2. That gives me negative 6. But remember, those are in absolute values, and the absolute value of that is 6. When I go to plug in 1, it's 4 times 1, which is 4, and add 2, again, absolute value. That's the absolute value of 6, which is 6. I want you to pause the video for a second, and I want you to do number 3 by yourself. So the answers you should get are negative 15 and negative 9. Take a look at the work. If it was different, if you still don't understand it, make sure you ask the next day. Number 4, it's a little bit different, and I want you to notice why. If we take a look at number 4, do you see how the 9 is on the outside of the parentheses? And in example 2 and 3, everything was between the absolute value. This is something we really want to note. So star this or highlight this. We need to isolate the absolute value bars. So before I do the A and the B, I need to make sure there's nothing on those absolute value bars. So to start this problem, I'm actually going to subtract 9. So then I'm going to get the absolute value of 5x equals 10. Now from here is where I'm going to separate into A and B. So A equals 5x equals 10, and then b is 5x minus equals negative 10. So again, it's super important that we isolate those absolute value bars. So I'm going to divide by 5, and we get x equals 2. And then over here, I'm going to divide by 5 again, not by x. And we're going to get x equals negative 2. So my solution set is negative 2, comma 2. Again, what I'm going to ask you to do is pause the video, and I want you to work on number 5 and number 6. And when you get to, well, both of them, I want you to plug in your answers and make sure that the answers you got work out. So hopefully with number 5, what you did is you isolated the absolute value of d again. So add 4 to both sides, and then you divide it by 3. So then you ended up with absolute value of 7, which produced negative 7 and 7. And hopefully when you plugged it back in, it worked out just the same. I want to look at number 6, and there's a couple things I want to point out. Did anyone catch that it equaled a negative number? Okay. So some of you might have written down the work that was shown on the screen right now with the A and the B, one equaling negative 3, one equaling positive 3. Now, if we take this and we plug it in, we're going to get 7 times negative 1 minus 5 over 4, and this is absolute value. And then we get negative 7 minus 5 over 4, which gives us absolute value of negative 12 over 4, which is the absolute value of negative 3. And I want you to think what the absolute value of negative 3 is. Hopefully you said it's positive 3. Is that what the question is saying? Does it say that it should equal positive 3? No, it says negative. Now, if you plug in 17/7, it's going to give you the same thing. So here's what needs to happen. Again, this is another one we're going to star. If, and only if, when you isolate the absolute value bars, if it equals a negative number, that means there is no solution. Because would there ever be a case where the absolute value equals a negative? So that's the question you want to ask yourself. Is there ever a case where absolute value equals a negative? And the answer should be no, because if you go back to our definition up here, it's a distance to 0, which should always be positive. So here's the thing with something like this. When you see it equals a negative number, you don't have to do any of this work whatsoever. As long as it's isolated and it equals negative 3, all you put down is negative, no solution. This should be something that we should see right away. And this brings us to our last 2 questions. And you can see this looks like a little trickier, right? We have 2 absolute value bars. But we kind of deal with it the same way. Very similar, at least. So the first one, I'm going to do A and B because the absolute value bars are isolated right here. We see that. I'm going to leave everything the same. Nothing changes. 4x minus 5 equals 3x plus 5. So the only difference is we drop the absolute value bars. And we will solve it. So I'll subtract 3x. I'm going to end up getting x minus 5 equals 5. And then I'm going to add 5. And we get x equals 10. Okay. Now, here's what happens to the b part. I still keep the left-hand side the same. 4x minus 5. But remember, it's a distance to 0. And we know that one generates a positive side and one generates the negative side. So this one was our positive side. And this one, we're going to do the negative side. So what you do is you put a negative outside of the quantity. So that's what changes. So I put a negative sign outside of the expression on the right-hand side. And then I distribute the negative. And then I'm going to solve. So add 3x. And that's going to give us 7x minus 5 equals negative 5. I'm going to add 5. And then I get 7x equals 0. So x equals 0. So we get 0 and 10. Go ahead and pause the video and finish with number 8. Okay, so hopefully on the last one you kind of got these two solutions. This one makes sense, it's 1. This one might not make sense because the variables disappear. Now, we talked about this last time. If the variable disappears and it's false, there's no solution. But because we did produce a solution with A, the whole problem isn't no solution. It just means that we only get one answer for that problem.